This is going to be, I hope, a short video about my experimental off-grid power setup. It's horrible in two ways. It's very unsafe in that it's all kind of tangled up here. The wiring is not wired in a very safe way. And I don't have fuses or enough shutoffs to make it safe. But it's a relatively low power system, and it's also just in the open here as opposed to being inside of some type of fireproof cabinet. So with those three things, the lack of cable management, the lack of fuse protection, and no safe cabinet for it to be in, those are the major things. Also, the BMS on this isn't very well done. It's not a very functional BMS. So 4 major things that are wrong with this system. But this is a 7S3P lithium nickel manganese cobalt pouch cell a123 systems, nominal 24 volt pack. It's 25.6, I think. And it's I run it up to 28.5 or 6 volts. I think it can run up to like 29 something. And I run it down to 23.8, 23.5. I think it can run down to like 21, maybe even lower. My WZ-REL-B DC to AC 120 volt output, 1500 watts, pure sine wave inverter. This thing is on 24/7 most of the time, and it's been on that way for 6 months. I mean, I turn it off now and then, but it's pretty reliable. This one has a little bit of an odd situation. There's probably a little knob inside here that I could turn that would give me a different output voltage. It's kind of high. When it gets up to like here, 27 something, it's going well above 120 volts. I'd prefer it to be down at 120 or below, maybe 115. And it kind of buzzes a little bit if it doesn't have a load on it. So I've got this DC motor load, or a universal motor load maybe. And if I turn it off, maybe you can hear that it's buzzing. Right now the fan on the charge controller is also making some noise. I'm going to turn the fan back on. And this pack has this little Dali BMS. It's upside down here, but hopefully you can flip your screen and read that. I don't have it wired correctly. I don't think. I've got it between the negative leads here. Maybe it's at B negative and it wants power negative. So maybe I have it wired correctly. And these are soldered on, and I'm not very good at soldering, but you carefully watch which number is associated with each lead and solder it on accordingly to the pack. And so this is, there are 3 pouch cells here, and this makes bank number 1, 2, 3, 4, 5, 6, 7. And on this pack, I left the old ribbon cable. It's got a lot of cool electronics on it, and maybe someday someone will figure out how to use the BMS on this pack. It comes with a BMS that's tucked in under this case here. You can cut them off. You can cut this off, and I use these little laser welded leads as a way to connect to these cells. You could get a really tiny drill tap and put a screw into this metal. I'm not sure what this metal is. It might be nickel plated copper. It's kind of thick. It's like a millimeter thick or so. Maybe almost 2 millimeters. This was wired in series, so here's the first pouch bank of 3 pouch cells, and then it goes up to the second one, up to the third one, up to the fourth one, fifth one, sixth one, seventh, and the positive power lead is there. I don't think this works. That's all I'm saying. I think internally it needs to get up to 4.15 or 4.2 volts per cell in order to balance the pack. And I have my charge controller cut out before it gets to that. I think, I can't do the math in my head right now, but 28 point something divided by 7 is less than 4.1, I think. So I don't really know. I don't know how to test whether this is actually working or not, but I can say that I've cycled this at least once a day for over 300 days, and it is 0.01 volts out of balance, which is amazing to me if it's just doing it on its own. Here's my charge controller. This is relatively, I mean, with a piece of electronics like this, you don't want any kind of error, and it does occasionally charge the battery beyond what it's set to charge it. It's set to cut out at like 28.6, and sometimes I'll find it charging it up to 29 something. I don't know what tricks it into going past its limit. It's possible that some kind of load turns on simultaneously with some kind of internal condition, and then it gets confused. I so happen to have been here every time that's happened. It's happened like 4 or 5 times. And I have this set up out in the open, and I'm watching it all the time. But I wouldn't necessarily recommend this setup for somebody who's not watching it constantly or willing to let their house burn down. Because, I mean, essentially I built this house, and that's fundamentally the issue here. There's no insurance. I run my own house off-grid, and if something goes wrong, I deal with it. I should be smarter about fuses and the BMS and the charge control quality, and I'm not an electronics guy. I don't really know what to do, how to buy the right items yet. I'm still learning as I go. But this has proven to be a very good charge controller, with the exception of that it occasionally charges incorrectly, very occasionally. And I have it mounted here flat, which is not great. It should be mounted in a dust-free cabinet. The little screws here for connecting the wires are kind of shitty, and it's got various limits, but I mean, it's working for me. I've got 4 300-watt nominal panels up on the roof, and they're in a 2S2P configuration. And at full noon sun in the summertime, it pumps out like 1200 watts or so. It's February now, and not quite noon right now. I think it'll get up to about 900 watts on a day like today. The panels aren't angled necessarily at the ideal angle. They're not super clean. They're kind of mismatched. They're all used, so it's not the perfect system. I have this set. This is kind of weird. Like, it detects that it's a 24-volt nominal bank, and then you set D1 to the max voltage, which I've got it at 13.8, but since it's a 24-volt bank, internally it knows to double that. These are designed mostly for, well, they work for, it's a pretty flexible charge controller. It works for 12, 24, 36, and 48 volt power supplies, or battery banks. So this translates to, what does that translate to? That's 26 plus 1.6. So I guess that's the equalized charge. I've got There's no real equalization charged for a lithium battery bank, so I'm not really sure what this is. I just set it at what I thought might be a safe setting, which in this case is 27.6. And this D2 is the maximum that it will charge it, which I've got set at essentially 28.6. It's this 14.3 doubled. And then this is where it cuts off at the low end. And I've got it set to 21.2, I guess. And I don't know what that means. So it has just worked pretty reliably. I've tried using a couple other charge controllers and they don't work nearly as well as this one. I've got these two breakers for the panels coming in. That's really the only safety thing I've got on the system. So I can turn off a breaker, and you'll see about the power cuts in about half. One of the banks of panels is a little more powerful than the other. They're not really balanced very well. So now I've shut off both of the cables from the incoming power, and we're almost up for the day to full capacity. So let's turn it back on. Bank 2 gives us 480 something on its own. Bank number 1. Gives us 300 something. That's pretty much it. I mean, if I'm running an air conditioner, I've got this Midea. I can't remember which one this is. I think it's the 10,000 BTU. If I'm running this thing at full blast, these wires can get kind of hot. They're maybe 110 degrees, 120, maybe hotter. It's, I guess the issue here is I'm in a desert climate where it gets up to like 110, 115 during the day in the summer, and I don't have a very well insulated cabin. So I'm kind of pushing this thing to its safety limits or past its safety limits. But so far, so good. No sparking, no fires, no explosions, no craziness that I haven't been able to handle. Also, I should note that this battery bank, it's got a pretty cool construction. I wouldn't be able to do this myself by any means. And this is the negative terminal, and then there's this little block here that's not directly connected to the negative terminal, but the bank comes with these nickel-coated copper bus bars that cross over here. I removed this one. On this side, I've still got the bus bar from the positive here over to this. Just gives you 4 connection points, and I think these are T30 bolts, screws. They're about, I don't know, 10 millimeters long. Pretty cool construction, in my opinion. This is another 2 packs that I've put into series so that I could get a 48 volt pack, and I've wired it up for a 48 volt Dali BMS. The Dali BMSs I mean, I haven't found any good BMSs besides Electrodacus, and he doesn't go up to 48 volts. Otherwise, I think some people have found one or two that they really like. I'm not certain I haven't ordered them from Alibaba and tried them yet. So, like, interacting with this, I have no idea how to do it. It doesn't show up. It doesn't have like a Bluetooth program. It has no interface. I'm not really sure how to make it work. Nor am I certain that it will work. I bought it because I think it's programmable, but I may have gotten the wrong one. But anyway, I've soldered all the leads on. This cover is on here, occluding that side. I left these ribbon cables on, but I removed the BMS that came with the pack. And I used the bus bars that it came with to connect across. And I don't remember if I had to remount some of the holes in the bus bars or shift them slightly. I don't think I had to. The packs have a gap in between them there. And I mounted them on this piece of plywood so that they don't move and cause any stress on these connection points. But so we've got, on this side, we've got this negative from what I've labeled as cell number 8 over to this side of what should be cell number 7. And, oh, wait, no. On this one, this is to a independent block. And it goes over to here, this positive of cell number 7. So that's what makes this possible. I could have used just a custom crimped thick cable, copper cable from this point all the way over to here. But I decided to use these native bolt-on bus bars.